The following content is provided under a Creative Commons license. Your support will help MIT OpenCourseware continue to offer high-quality educational resources for free. To make a donation or view additional materials from hundreds of MIT courses, visit MIT OpenCourseware at ocw.mit.edu.
Okay, so toolkits to help customers develop and modify products. When we understand that users can innovate, then we can figure out whether it might make sense to help them do so. You know, when I talk to you about lead users, that's users naturally innovating on their own. And when you go and hunt for users via the lead user method, it's almost like hunting and gathering. You know, going through the forest, the users grew on their own, they developed the innovations on their own, you had nothing to do with it, and you discover them. But there's also farming, right? You know, eventually people who were hunter-gatherers said, well, maybe instead I'll sort of grow things right here. And so toolkits is that analog. Basically, with toolkits for user innovation, what you do is you say, I think I'm going to help my user innovator, and I'm going to help him in a way that in turn links him closely to the products I can, for example, produce. So that's what we're going to talk about today. And I'm going to give you an example of a toolkit. How many of you have seen Fold It? Video of Fold It. Fold It is very cool. And that's an example of a toolkit. And also I'm going to ask you towards the end of the session to think about whether you could design a toolkit for the company that you were with or might be with, but something that you know well. Just to think about the possibility, again, to embed it in your minds. So what's the issue with toolkits anyway? Well, the issue that a company often faces is that, you know what, we internally cannot afford to develop innovations for our users. Even if they ask us, if their demand isn't sufficient or sufficiently well understood, we simply cannot do it for them. And so what you typically see is companies saying, well, if you want X amount or more, we can develop a special for you. But if you want less than that, we can't help you at all. You know, just go away. Well, in line with that pattern, what you find is that some fields are strongly affected by this relative to others. And a field that was very strongly affected by this was semiconductors. Basically, a semiconductor is a powerful thing. A custom semiconductor is wonderful for all sorts of applications. But there are big tooling costs on this thing. There are costs to actually get ready to make a custom semiconductor. There are costs to design the custom semiconductor. There are issues with respect to understanding exactly what the customer wants. So what happens is that some companies like Intel can afford to make what's called full custom chips when they make their ICUs. These are full custom chips designed from scratch. They can afford to do that because many, many people want them. But if you come to them and say, you know what, I'm building a new toy, and I'm going to build maybe 10,000 of these toys, and I want the voice box of a robotic dog. You know, they'll say in the full custom, you know, it's like, what? You know, we can't do that. You know, we no way. And then if they did do it, they know damn well that what would happen next is that you'd be saying, great, you delivered my chip, but it doesn't go woof woof the way I wanted it to. And you say, well, darn it, for 10,000 units, now I'm going to go from woof woof to some more somber sounding woof woof. I mean, the whole thing is just useless. It's too costly. And so what happened in many fields today, and in semiconductors in particular, was these companies making what are called full custom chips told people who wanted something that was not wanted in great demand to go away. They said, can't help you, go away. So basically what they could do is they could serve the few customers at the top who wanted something that was really in high volume. The rest of them go away. They didn't know where they went. And it could be some source of competition for them or whatever, but they just in their business model, they couldn't handle it. And there was a company then called LSI Logic that figured out how to fill this gap. And what LSI Logic did was they said, look, when you design a full custom chip, what you've got in your company is design tools. What would happen if we made these design tools in a user-friendly way so that the customer could do it for himself? And the existing manufacturers, like Fujitsu and TI, said, you've got to be out of your mind. The tools are the crown jewels of this business. We would never want to give those away. That's a terrible idea. But LSI had nothing to lose, and there were some tools around, and so they put them together. And I will fill in for a minute. There was an easier way to make something called gate arrays, which allowed them to do this, that was devised by Mead and Conway, but I'll get to that in a minute. Anyway, they put together a design toolkit for users. And the idea was, great, now what we can do is if a customer comes to us, really wants one, can't afford 10 million or to pay us the huge tooling costs involved, we'll give them the tools, they'll do it. And it's a great business for us because they have to go through our foundry to make the design. So in a sense, we're outsourcing the design to them, but they still have to go through our cash register. It's very much similar to when they first came up with supermarkets. Prior to supermarkets, the staff in the store would go and pick up from your list each of these things, and they put it in a basket, and they bring it to you at the front counter. And then they figured out, well, darn, you know what? You have to go through our front door. Why don't we use your labor to pick the stuff off the shelves? And then what we'll do is we'll charge you as you go out the door. So they introduced this, and it became a huge success. I mean, basically what happened was that they were able to all of a sudden tap into a whole bunch of new customers. And the customers at the top of the pile, who were the ones that were loved so much, or at least serviced by the existing full custom companies, those guys, they abandoned the full custom companies. They said, well, wait a minute, we want to design our own too. We don't want you guys holding our hand and getting it wrong. We're going to design our own. And so that's really what made them pay attention. I mean, the marketers in those companies were saying, what, you don't want me to hold your hand? And they said, no, we don't want you to hold our hand. We want to just get the heck out there, get some tools, and build what we want for ourselves. So basically then, a whole new market had been opened up by a toolkit, and the toolkit basically was something that said, you know what? We'll help you design it for yourself. Now, here's the general principle of a toolkit. The basic idea in terms of ordinary sort of market research, find a need and fill it kind of activities that you've all been taught is that you have a need and we make something for you. But if there are a lot of people, smaller markets that each have a different need, this gets costly because you each time somebody has a need, you have to understand what they want and make it. You have to understand the voice box for the robotic dog. You have to understand how that works so that you can make a responsive product. So, what LSI noticed and what many people have since noticed, like, for instance, Travelocity, is, my gosh, you know what? All the customers want the same information from me in the form of a design tool. I can have them design their own. So as an example, just think about Travelocity. Travelocity, it used to be, maybe you don't even know this, but it used to be that you had a travel agent. I don't know if you ever had a travel agent. But you call up a travel agent in the old days and you say, you know, gosh, I got to go to Des Moines, and then I got to go to Paris, and then, I think I'll visit Uncle Oscar in Portugal. And the poor travel agent is listening to all this, yeah, right, about Uncle Oscar, and, well, you know, do you want to stay for a long time with Uncle Oscar? Sort of trying to pull out all the information so that the producer, the travel agent, can design the trip. But what is the travel agent doing? The travel agent has access to some hotels, to trips, to plane flights, right, to the costs of them. Give that information to the users, which is what Travelocity does, in some user-friendly way. And all of a sudden, you don't have to know about Uncle Oscar anymore. In other words, all the specifics that the company needed about the need to compile a trip is no longer needed under this toolkit mode. So that if you can do it, it gets really much cheaper. If you have a market where everybody wants basically the same sort of basic principles from you, then you can do it. Okay? And so that's what we're talking about here. The idea is users innovate on their own. They'll innovate better with toolkits in a way that you can fabricate something for them if you give them the design rules and the information they need to do it in a way where they don't have to be specialists, in a user-friendly way, right? So you have possibly, when you've been enormously impatient, leaned over the counter and looked at what the American Airlines or whatever person is doing on their computers. Have you ever seen that screen? Just masses of numbers. Not user-friendly. But if you look at Travelocity or something like that, all of a sudden that same information has been converted into a user-friendly form. Okay? Now, this process has been progressively repeated in many industries. And so now you wouldn't even recognize the change that has occurred over the last 20 years. Basically, it's amazing. So first there were these full custom chips. Then there were user-designed chips that manufacturers produced. And those were called like ASICs, application-specific, IC, integrated circuits. And now they're EEPROMs, basically something where you can program it yourself in the field. It's gotten cheaper and cheaper, and now you see things on the web like this. Designing your own chips, the silicon variety. That's something you do with millions, if not billions of dollars of equipment and large fab plants. Well, isn't it? Actually, no. You can design your own chips at home with a PC using no more than $50 worth of equipment, and I'm going to tell you how to do it. Just think what a huge transition that is. Just enormous. It converts something which was a technology that was basically inaccessible to users because it was so specialized into something that any one of us can do. Tremendously empowering. And as long as that company can still sell you the EEPROM, the specialized chip or whatever, the company benefits too. They get to sell more chips. Okay? Now, so again, why ASIC customization is cheaper with toolkits? Because there are many users and you don't have to understand their information anymore. Okay, so now let's go to how do you design a toolkit? There are two major tasks, and in the end, what I'm going to ask you to do is think about whether you can figure this out in the case of your own company or some example. Remember, again, I always keep telling you that unless you play with it yourselves, you're not going to sort of have a good handle on it and good feel for it. So I'm going to ask you. Now, there are two tasks. The first one is to separate out development tasks that are need information intensive and assign only those to users. Okay? The next one is to develop the tools, but let's take the first one first. That's a gate array. Now, a gate array is something that's really a tremendous architectural change in how you design semiconductors. And I will give you a much more user-friendly example in a minute in terms of pizzas. But let's stick with gate arrays for the moment. You say, no, let's get to the pizza, god damn it. Anyway, let's stick with the gate array for the moment. So there's a lot of information in designing a chip. This would be a daunting task for any user, right? That would be really hard. You know, you have to know what a chip is. You have to sort of know something about designing gates and solid state and so on and so forth. Big mess. Two people, Mead and Conway, figured out that if you created a chip that had on it these digital logic elements, these are logic gates, ands, ors, and so on, NAND gates, you can use them in any way. That's where all the semiconductor expertise resides. That's where you need solid-state physics folks to figure out how to make them small, how to make them fast. And what Mead and Conway showed, basically, is that you can design anything based on those gates that has to do with digital logic. You can design a dishwasher controller. You can design artificial life. You know, anything in between. So what's happened here? Well, if this is the case, where's the need-specific information? The need-specific information, the information that the customer has, is simply how to interconnect those. That's what determines whether these gate arrays are the voice box for a robotic dog or artificial life. It's the interconnections. You do not have to know anything about semiconductors at all. And if you think about it, too, by analogy to what I told you about Travelocity, the same thing is true. In Travelocity, you don't have to know how to fly a plane. You don't have to know if it's made out of metal or chocolate. You simply have to know what it costs and whether you can sit down, right? So, these tools then neatly separated out and made a small task out of the things that the user would have to do. And so that is what LSI logic gave users tools to do. They didn't give them tools to design semiconductors. They gave them tools to interconnect logic elements. And that turned out to be easy to do in a language that the engineers understood, which was Boolean algebra. So you just did it that way. Now, therefore, the first thing that you have to think about, in effect, is how do you simplify the tools so that a user can do it? How do you simplify the overall task? I'm going to show you a video right now. And it's an amazing video in that regard because it's called Fold It. And it's about people who are figuring out how proteins can fold. And the toolkit has been designed by scientists who want to understand the functioning of proteins in the body, which is determined by how they fold. and the computers can't really figure out minimum energy folding, people are pretty good at that. But a lot of people don't know anything about proteins. So what they did was they designed a toolkit and a game called Fold It that gives the users just the information they need without any knowledge of chemistry or anything else to do this task. Okay? And it's very cool. So the reason I'm showing you this is that it is possible in most cases to design something where you give the user just the simple task the user needs to do. Okay? It's very cool. Watch this. This is 6 minutes. It's amazing both in terms of engaging people. I mean, one of the things that one has to learn about is gamification, where what you're doing is you're making it more and more interesting to do something, and therefore drawing in people into real-world tasks that are useful. But specifically here, the point that we need is that that is a complicated thing which has been made into a toolkit that users who know nothing about protein chemistry can use. And so when you get to your issue, just like this one here, ended up designing a product in such a way that the user could do what the user had to do to solve the user's own problem. What I'm going to ask you to think about is, again, how to sort of take out the things that are user content free and not trouble the user with them, and give them only the stuff that has a user content. Okay, so now, let's see here. The next thing is, what does the user have to do? Okay. What is a toolkit? What should the content be to help the user do what the user needs to do? And basically what's going on here is that you need something to carry out trial and error design. You need to be able to try something and see if it's right and change it if it's not. In the case you just saw of Fold It, what was happening was you were trying things out, and it was showing you by whether something stayed red or whether the energy dropped and so on, whether you were right or not, or sort of right, or getting on the path towards right. Now it turns out that every problem-solving task has this sort of structure to it. That is, you design something, you build it, you test out your solution, you analyze your solution, and then you go back around again if the solution is not what you hoped it would be. The way this is termed in the literature is kind of confusing. It's termed trial and error. What trial and error means is that you design something that contains everything that you think needs to be in there. You think it's the solution. You do your best. And then you build it and you run it, and the error that you discover by your analysis is the part that you didn't expect. Right? It can be a positive error. Wow, that works even better than I thought. It can be a negative error. It's the part you did not expect. So now, just to get a sense for this, you can do it in your head, or you can do it with elaborate laboratory equipment. So for example, if you're trying to do a semiconductor, you'll design it in CAD, and you'll make it, and you'll test it, and so on and so forth. Trial and error learning. But you do the same thing whenever you think about things that are problems. So here's a question for you. And just watch your own thinking as you think about what to do and see if it doesn't follow this pattern. Okay? I want you to think of whey to have a sit-down dinner for 50 people in your apartment? Now notice what's going through your head, right? It's like, you imagine something, right? Well, I imagine 50 people crowded into my apartment. Maybe they won't fit. Okay, so what's going on there is you're saying, I imagine 50 people just sitting down, no room. You know, that's your analysis. And so you go back around and you say, well, what can I do? So who's got 2 or 3 cycles they can explain to us? Who's got an example of 2 or 3 cycles that you went through in this problem? Yeah.
I live in a studio on campus, and so the illegal thing for the people room. So then I cycled to use another room.
Okay, so you live in a studio on campus, and you couldn't have 50 people in there. Now notice, I didn't say that they had to be there all at once. Right? Okay, this gets harder. They can sit on the floor, right? But you're cycling through. Okay, so that's the idea. Now, if you think about the case of Travelocity, that's a toolkit, because what you can do is you say, I want to go on this trip, and you try it out, and you say, no, that's too long. You know, it shows you the length, it shows you the price, and you say, no, that won't work, I'm going to try again. What if I go through Munich, or whatever? And you try it again, right? It's giving you the information. Now, if you think about the Dell website, where it's construct your own computer, that's not a toolkit. How many of you have ever used the Dell website? Have you? To quote, design your own computer? What it does is it says to you, how much RAM do you want, for example? It asks you a series of questions. How much RAM do you want? And you don't know, right? You don't know how much RAM the programs you're using take up. So their default that they hope for is, a lot, right? Then they say, well, how big a disk do you want? You say, you don't know how much stuff is there. Humongous, right? And you go on in this fashion. But you have no way to test whether your decisions or choices are the right ones and reboot before you buy it, right? They deliver it to you, and you're sort of stuck with it. If they had turned it into a toolkit for trial and error learning, what they would have done was say, okay, you say you want this much RAM, you say you want this size of a disk. Let's cripple a computer at Dell to run exactly that way. Now, upload some tasks and run them. And then now go for the next size of RAM, and let's run it again. Oh, you saved 10 seconds. Is that worth it to you? You're getting some way, some tools, just like in the case of Fold It, where you had red areas. You're getting tools to let you understand whether what you did was on the right path for you or not. So that's the idea of a toolkit. It has in it that kind of design, create a prototype, take a prototype for a test drive, compare expected and actual results, and iterate if you don't. So this is if you're not satisfied with the results. So this is something you have to think about. When you give users a toolkit, you're giving them tools to actually try stuff and see what the answer is. Now the next step that people say is they say, well, you know, the trouble is that the user is an idiot. E.g., the user does not understand our language. So what you have to understand and think about is not to teach your language to the customer so that they can use your toolkit, but rather understand the language the customer already uses. So this is an example. My daughter, when she was 8, she's now 20, but when she was 8, she contributed this with great pride, and I've kept it ever since. This is the Barbie hairstyler, okay? And my daughter's name is not Jess, but anyway, that's whatever. My daughter doesn't look like that either. But anyway, So the idea of that toolkit is that you can, over here what you have is a virtual comb and a virtual brush, and you can change the colors. So all the variables that are in a hairstyle are under your control. And the tools are things that you're familiar with, like a comb and a brush and scissors. And so then what you do is you put your face into that thing, and then you can design a hairstyle. Now, why is that useful? And that is now in some professional salons too. That's useful because in this case, producers being told the need by users doesn't work very well. Okay? So I go up to a hair, if I had hair, I would go up to a hairstylist, or you would go up to a hairstylist, and you would say something very useful. You'd say something precise, something like, I want a haircut that's businesslike yet casual. And the designer would say, oh, right, I know exactly what you mean. And he would go cut, 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 snip, snip, snip. And of course, what happens is your hair is wet during this process, so you can't even see what's going on. And at the end of it, he says, voila, madame or sir. And you say something like, you have ruined my life. Right? Now, what's the issue there? The issue is that you were not given the opportunity to do trial and error learning. And if you asked the hairstylist, well, couldn't you do that? He'd say, no, the customer does not understand layer cutting and all these things that I know. How could I possibly, have the customer design a haircut? But what you do instead is you say, but wait, what is the customer's language? The customer's language is looking in a mirror and deciding whether they like it or not. And responding in some way, lengthening, shortening it, doing whatever they're doing, right? So their language is something that they're perfectly able to do. They style it, they know what a comb and a brush and a scissors are, they look, they change their minds, they go back and forth. And what you can then do is once that styling has been done and the customer's satisfied, you can have the program turn it into instructions like layer cutting. You don't have to do it, right? So you've said to the customer, never mind the stuff you don't know. We're going to build a toolkit that allows you to use your own language. Now here's a slightly more complicated example. This is a user toolkit in the case of flavors, and this is an actual one. The story there and the problem is that there are many customers, just like for Travelocity, but it has always been a highly technical field. Okay, so the design of flavors is something that flavorists study years to do. They're chemists, and at the same time they have a wonderful sense of the ability to combine flavors and so on and so forth, and they sort of do that. And they have customers who have in their minds something they want, quite specific, a taste. But they can't explain it to the designer. So they come in and they say something like, I want something that tastes like the peach I ate in Alsace in 2008. Yeah? Or, I want something with gusto. And so what the chemists do is they turn to each other and say, do you suppose that's butyric acid? I mean, what is gusto? Right? Very difficult. So what you want to do is something like Travelocity. Namely, you want to transfer in a user-friendly fashion to the customer a way to design his own flavors. But you can't teach him about the chemistry. That's hopeless. And anyway, you don't want to because you want to keep that proprietary. So what do? This is what they did. This is now particularly a strawberry. And these are the notes of a strawberry. A strawberry has flavor notes. Now normally, when you were designing this inside the firm, these flavor notes would be under chemical names. But what they did, this is IFF, a company that is the biggest in the flavor business, is they did a survey of their customers and they said, taste this and tell me what term it is to you. And so they would taste it and they would say fruity or something like that. And then what you do is you take those notes. This is now a spider chart where that red thing is something where you can increase the amount of each flavor note by pulling the red thing out. The more you pull it, the more intense that particular note is. And what they then did is they said, okay, so we'll name it your way, and you just pull those things out, and we will fabricate the flavor, and you taste it. Okay? So the customer is just like when he's doing Travelocity and saying, I think I'll go through Munich. No, I think I'll go through Milan. What's happening here is, I think I want something with a little bit more fruity taste. No, I don't. Now that I taste it, I want a little more of the green taste or whatever it might be. Okay? Converted, now those people have to do nothing and know nothing about chemistry. And it's a marvelous toolkit from the point of view of the producer because they get to keep secret the actual chemicals that are used. Right? So it's just simply user design, IP protected, and so on. Now, what's going on underneath the toolkit? What's going on, just like in the case of Travelocity, is a lot of stuff. Stuff that the user doesn't need to know about. So, for example, one of the dimensions on some of these flavors is jamminess, which is I'm assuming it tastes like jam. I'm not sure. But anyway, jamminess. So the user has a lever there, right? Remember this thing here? One of these notes now would be jamminess. And the user simply pulls it out. And you'll notice that over here, there's the other thing the user wants to know, which is how much does it cost? So it's computing the cost underneath as well. So that now I get, it tastes good and I can afford this. You know, it's like $100 a pound or whatever it might be, or an ounce or whatever it might be. But what's going on underneath? Well, what's going underneath is not that you're just adding more and more of a particular chemical to make a flavor note. What's happening is that if you're a skilled flavorist, what you know is that the degree of jamminess as it goes up, there's an area here, a range of flavor system A. And it only works over here. And then if you keep cranking up the jamminess, it starts to taste burnt. Something else happens. And so you switch over to flavor system B, and maybe to flavor system C and flavor system D. All of that is invisible to the user, but it's going on underneath. So that you're pulling on this note here, and what's happening is suddenly it switches from A to B, and B is more expensive. Suddenly the formula cost jumps up. That's all you have to know. It's giving you the stuff you need to know. It's simplifying what is actually great complexity in these things. Yes?
But if something that's friendly to some of users is also not friendly to some other users, especially the larger groups, large sample populations. Should we utilize some kind of on-the-fly approach constantly update?
What will happen? Yeah, so you're asking what if different users have different languages, or it's unfriendly to some and friendly to others? So what happens is that the users are always giving you feedback on the toolkit. So you can't necessarily predict all that. So what you do is you choose an area where the customer really cares, so that he'll go through the difficulties of a nascent toolkit. And then what you do is you improve it with suggestions, and you sort of expand out to other customer groups and so on. It's a work in progress. It's iterative. Okay? But that's a very good question. Now we're going to get up to how you can do it. Okay? So here's what I propose that you do. I want you to think now, what have I told you? I've told you you have to do, you want to separate out all the stuff you can separate out that doesn't have anything to do with the user, right? You want to just pull out those tasks that have to do with the user's need. Then you want to give the user the tools to do that in their language. So what I want you to do is think about that. And I'll give you one more example. Okay? We're in a room here together. And in this room, you and I know the functional face of this room much better than does the architect. We live in it, right? So we're in this room, and you might say to yourself, I'd like something a little different here. Let's just say, I'd like the ceiling a little higher. Okay? Now, the technology of structural engineering is cut and dried. Just for a building this size, totally cut and dried. So you could, just like in the flavor story, you could just take an image of this room, push up the ceiling, and all the computations would go on in the background, and it'd say, okay, so we have to put in bigger beams or whatever it might be, and the cost will be such and such and such and such, and the consequences will be that and that. And you don't have to know structural engineering, right? So most anything you think about, when you think about it from the functional point of view, the user already has a language. That's how they deal with it. So that's what you want to think about. Okay? So identify a type of product where you know it pretty well. You can say where the demand for customization is strong. That's where this would be helpful. And then think about the tools your firm already has. Right? So the firm already has tools in there. When I come in and ask my engineers in a company to design something, they turn to their tools. Right? They say, okay, I've got a CAD program for this, I've got that and that and that and that. Fine. Maybe you can convert those so that they are user-friendly. How would you adapt the basic product type to separate out need-intensive tasks for user customization and describe what it might look like? Okay? So that's easy for you to do in 10 minutes, right? I have faith in you. Just re-engineer your whole industry. Piece of cake. So talk to each other, think about it. I know you can do it.